Testing, testing. Hello, welcome back. And today we are streaming UI dev on the Division inspired Holomap UI. And so we're going to be finishing off with some marker systems. We'll do a registry where we register those markers, and then we'll translate them to our local space of our mini map that we have situated around our player. We'll also do some graphics for some glow lines that come off the top of those, and we'll do some zoom in functionality as well. So let's get started with that. Let's jump over to our scene here, smash on our 2-hour timer. Okay, so we've got these markers to create, and I haven't opened Unreal yet, so let's get going with that. The way I want to do these markers, I'm just going to do a generic single size for this, I think. I'm just going to do something like this one. Maybe we'll do some color variations. The idea is going to be that we actually create these in our world. We place these down as objectives, essentially. We could add the component to anything, and we will represent those on our canvas. So we'll get to that, but another thing that I want to do for polish reasons is just the ability to zoom in and out on that map. So we have the project open now. Got some new plugins. Let's go and open the map that we want. And we'll just hit play to take a look at where we got to last time. So we had this mini map that we can zoom in and out when we open it. I want to use the scroll wheel to affect the scaling of the actual map itself. So I want to scroll the wheel back and have this map and all of its elements change scale. So let's start with that. We'll open our IMC. We're just using this episode 5 one here. We've got the map UI, or the map event I should say. So I'll say IA map zoom. This will be a 1D float. It's going to be controlled by the mouse wheel. This is the mouse wheel axis. We'll open up our character, and in our Holomap where we've got our original map input, we'll also put map zoom. And whenever this is being triggered, I'm actually just going to put a print on here, because if this acts the same way as previous axis worked, then it's going to print this string constantly. We'll just have a look and see what happens. Nope, so it only happens when we actually trigger it. So that's good news. What we can do is take our Holomap, get a cast to that, and then we're going to create a new function inside our Holomap. Let's open up the Holomap here. Let's create a new function. So custom event. Oh, we could do an actual function, but we're going to do a custom event. Set. We'll do edit zoom level. We'll actually do this as a function, so we'll collapse this to a function. Or I think you can actually convert to a function. Either or. Edit zoom level, and we'll have a delta for this. We'll have a boolean for increase. And so now we can call that on here, set zoom or edit zoom. And then it's just whether or not this value is more than 0. And if it's more than 0, we're zooming in. That's our input. And so from here, what we can do is we can hold a current zoom level. We actually have map scale already right here. So what we'll try is min max zoom, or min max scale, I suppose we would call it to keep it the same. We'll categorize some of these. This was for a test that we were doing. Just move that out of the way. Put this in refs. Alrighty, so what else have we got here? We've got compass size. We'll just put this in configs. Line meshes. Yeah, that's for our path. And then we've got shown, which is part of anim. Okay, so we've categorized some of that. Let's categorize some of our other functions. This is compass. Waypoint path, we'll put that in path. Then we've got zoom level. So we'll just put that in core, I guess. Okay, so we should have a min-max zoom scale. We'll make that a vector 2. So currently we have 0.1 scale as our minimum zoom. Actually, what I want to do is make this a float array. So we'll just call this zoom levels. And we'll essentially find this to determine where we're at. And so let's add in some zoom levels. I think by default the map scale is 0.1. So let's just add a bunch of zoom levels. I think we'll go 0.02, 0.05, 0.1, 0.2, 0.5, 1, 2. This, in fact, one times scale is going to be like the scale. If we zoom in that much, we should end up with the buildings actually being relative to us. And so what we'll do is we'll add a value to whichever one we're at, which will be based on whether we're increasing. So if we are increasing, we're going to add 1 to this, and if we're not, actually we're going to add -1 because we're going down in scale. We're zooming in. Actually, there will be 1, and then it will be -1 for this, and then we just ask if that's a valid index. And if it is, then for now we're just going to change map scale, but we might actually interpolate this. So what we can do now is just get that value and set that as our map scale. What we need to do is make sure that that map scale is used in various places. So currently it's used on this randomize, which we're not using. We've got update PCG, which is the world location, so that's good. It's not changing the world route's actual scale. So let's set relative scale for this. I think our world route is currently 0.1, yeah. So we'll set that up. So let's have a look at how broken that is. So it actually works immediately, which is great. We can still run around on this. We're noticing that some of our elements get a little bit harder to read. I would say. So what I might want to do is increase the size of the spline in particular. So let's have a look at that path. we'll use map scale as a property to power that. So let's go to our path, update waypoint path. And here we have a scale in here, start scale. So we'll do a set scale, set start, set end scale. Just move these out a little bit, plug this in. So this should sort us out for the scaling. We'll take the map scale. Currently we're at 10 times scale. What I'll do is I'll map the range of this from, I'll say, from 0 to 1. And I know that closer to 0 we want to be 10. We might even want to be 20. And when we're fully zoomed in, let's go for 5. We'll see how this works out. It's not great down there. Go for scale 40. I mean, I would say that this is too small, but if you do have a large city, this is quite cool. We get to a point here where we hit this value and then we zoom again and we actually end up shrinking. I'm going to have a look at what's going on there. Scale is currently 0.5. And then map scale goes to 1. So, not a fan. I'm going to change this to path scale. Path scales, I guess. And what we'll do is we'll actually get and find. What we'll do is we'll create a quick function, get zoom level. We'll put that in our core. We'll make that pure. That little function that we had here, it's going to be what we use here. We'll return that. Because this isn't going to change any state, we can also go into advanced and make it const. So if you ever try to change state in this pure function, it won't let you. How performance heavy is it? Let's take a look at that. Let's open up the CPU profiler in a moment, or the game thread, or any of those kind of things. We'll leave it off. We'll remove it from the level, and then we'll actually add it back to the level afterwards. And then we'll take a look at the GPU as well. I know that the material shading on it is in the red. But first we'll finish the zoom scaling. Hey Zero, how's it going? So we've got this new variable here. We'll just drag this in. That's our zoom level. That's all looking good. Got our get zoom. Got our event graph over here on the left. Let's just close all other tabs. We have an update waypoint path here. And so we'll grab a scale directly from our path scales. And so we can essentially map this so that we can control it a little bit more verbosely. So at 1 time scale, well, let's just have a look at how this goes. I think we were at 0.1 before and we liked 10 scale at 0.1. So let's go 20 here and 40 here. Let's go 5, 2.51. I think I'm going to double all these numbers. That's feeling good. Now let's get that change in the variable to become lerped. So we'll promote this to a new variable called desired map scale. Put this in a function, collapse the function, update map scale. Have f interp. We'll do f interp 2, which has a bit of a curve, and so we'll use our current map scale and our desired map scale. By default, this is 0.1. We'll use delta seconds, and we'll use a map scale lerp speed in here. Let's go and have a look at that, which goes into this function. Now we've got a little smooth lerp going on. We can cut this and put this in our tick. Let's take a look. So immediately we get, we're not going to be able to find the property of this, which is funny, because because we've now changed this from being exact to like lerping over time. So what we should do is actually just promote this to a variable called map zoom level. And by default, I believe that is 2. So we'll save that as 2. And this is the reason why we make a function, because when we start getting issues, we want to change how that feels. Hey, Delirian. Unreal struggle is real today, yeah? Is it the classic crashing? And Delirian insane, yeah. We're about to lerp this zoom scaling, so we'll take a look at that. So we have an edit zoom level, which previously we said, is the index valid. So we technically don't need this now because we have this variable, but it's fine. We're going to leave it just in case we change it again for some reason, which we won't. So we're going to save ourselves the headache of having extra functions that we don't need. We're just going to remove that function. So in the update waypoint path here, we're just going to replace this, and then we're going to we're going to remove get zoom level as a function. Okay, so this isn't lerped, which is a shame. There's a bit of a shame. We do know that there is a scale factor involved here, where at 0.1 we're 10. I wonder if I can just do this by a multiplier, because map scale will be lerping, and so I kind of want to put that in as a multiplier. Currently path scale to zoom level. Let me just use GPT to speed up the process of doing math. So I should be able to paste this in. Map scale, zoom level, and then I'll take that variable. Path scales here. Well, yeah. Map scale, path scale. I want to multiply map scale to result in path scale with a variable that make bigger. So it should just give me the algebra for this. I wish it wouldn't regurgitate what I just told it, because that's kind of annoying. It's non-linear. Oh, great. Well, yeah. Give me the bloody math. Why is it giving me an entire... It's averaging or getting us close to, I guess, a simpler math. So path scale is multiplier exponent. Multiplier exponent, okay. Let's get that going. How do you do an exponent in Unreal? Power. Yeah. Ah, there we go. There's the exponent. Cool. Okay, so we want map scale. Got a multiplier that we want. So path scale multiplier. Plug in, which is divided by. This is fun. Divided by map scale by exponent. So we'll do path scale exponent. Exponent. Plug that in. And so the values it's giving us, multiplier is 2.5. Exponent is around 0.9. Kind of cool. We're not, so we haven't properly updated our edit zoom. So here we've got, if this is valid, and then it tries to get the value. So we don't, well, we do want to do that. Oh, and we need to change map zoom level. We do need to save it. So if that's a valid number, we do need to save this out. So we'll make sure that we're doing that. Use some reroute nodes in here. Happy days. Okay. So that sorts us out there. Let's hit play again. So now we go too large. See, it's funny because it's supposed to be a valid index. So how is it going out of bounds if it's a valid index? Access none. Yeah, that doesn't make any sense. That's, oh, I see why. Because we set it and then it's accessing this edit again. So that's something to be mindful of is don't do that because it's actually referencing this previous node. Let's go back in. So we've got our zoom. I've noticed that the grid is a little strange. They're not scaling from center, right? I do want to make sure that this is actually, yeah, so we get to a point where it's actually one-to-one with our world, which is pretty funny. So we're now looking at a one-to-one scale representation of the world, which I think in retrospect what I want to do is like kind of clamp you around here. So let's remove some of our zoom levels. Let's get rid of path scales. I don't want 0.5 or 1. I think 0.2 is enough. So this is the closest you can ever go. And then this is the furthest. The grid scaling is a little strange. I'm not a huge fan of that, I will say. It's like, is it still, it's not really wrong. It's still scaled kind of correctly, although I think the issue is I need to change the scaling on the grid, not the scale of the mesh. At least the waypoint line is still looking good when you zoom out on the city. I just want the grid to behave in the same orientation. So our plane is not attached to our world root for good reason, because that world root moves. Let's take a look at what's happening to our plane. Nothing is happening to the plane. Which then begs the question, if the plane is attached to the default route, and I don't think anything else is using this map scale. This is just a test. I should just probably make these red. Let's move those over there. Okay. In fact, let's make a new graph just with test. And I just don't want these in my graph, so I'll just put them in here. Okay, so let's close everything down. Why? World route changes, that makes sense. Our waypoint path updates its scales based on the zoom level. We set up our desired map scale, which informs our lerp. We have map scale, and then we change. We immediately, oh yeah, and then we actually apply. Yeah, so apply smooth map scale. Update smooth scale. Okay, so that's cool. Got an error going on with some statics. So it says the BP Holomap's default scenery is static. If we make this movable, then maybe we stop getting errors. Okay, so when we scale, it's strangely editing the grid. So I'm going to change that in a second. I'm just going to remove this print string because we don't need it anymore. We know how that behaves. Thanks, Matt. If you're still around, let us know what you would like to see in another session, different asset too. I'm not going to be carrying on with this asset after this episode. I want to move on to one of the other planned things, which is like Slay the Spire map UI or Tarkov inventories or things like that. So different UMG next time, which should be around 10 o'clock today. That's the plan at least. We're 8:45 right now at my time. So yeah, in an hour and a half I have a quick break and then I'll come back and we'll do a different UI from a different game. Okay, so that's working fine. I don't understand why my plane changes scale at all. I'm going to find references to this. Nothing's affecting it. So let's just print this. Yeah, so that doesn't change. That's fine. There is a set vector in PCG world which gets the actor location. This is just the world location of the route, so that's fine. It does get the actor location of map location here. And I think that's what's informing the grid. So let's open up our m_grid. So we have this map location here. And so that ends up offsetting the world aligned grid texture. Someone in the previous stream recommended like just drawing a massive plane that essentially just moves with the problem with that is you're then drawing a plane across the whole world, and you'll see when I hit play here and I take a look at this, imagine if that red plane was across the entire world. You'd end up in the bad for the whole world. So I don't want to do that. Interestingly, this is always rendered as well. So I might need to hide this when... So quick optimization. Let's just go into... There is an animation. So we're just going to switch here. If this animation was finished and it was in reverse, so not shown, then I want to set visibility or set hidden in game to true. And if we're playing it forward, I want to set the visibility to, well, the hidden to false. The reason for this is if we go back in here, we take a look, you'll notice it actually hides the actor. It doesn't hide the attached PCG world though. So we will need to also do that to PCG world. What we'll do as well is on our begin play when we init, we'll just hide both of these to begin with. Did not work. Needs to be true. Take a look at this. Got a normal character, press tab, and then it goes away. So little optimization. Still looks the same. It's just that when it's shrunk away, it's no longer affecting our rendering. It's not actually there. So that's cool. Okay, now, so where are we actually at? Let's get rid of our prints that we just added. We have got our nice scaling map. We can zoom in and out, and we want to fix the grid. Okay, just looking at that grid one more time. So it's because the origin of this PCG world is around about, you can imagine this is a bounding box. I reckon the origin is around here at 0. So it's just moving with the sort of corner 0. The scaling, maybe that will fix it. So we need to grab this and set scalar param value on materials. We'll just call this map scale. Plug this in here. I think we just need to apply it to our material. So if we make a scalar variable called map scale, that's now going to affect this. So map scale by default is 0.1. We've got this grid texture. We are offsetting it here. Our world size here, I think what we want to do is potentially, we want to inversely affect the size of the grid at the same time, so that 100 at 0.1 is always retained, which means if we say 1000 in this case and say that's the texture size, let's just take a look at how that behaves. It's the wrong way around. I think it needs to be a division. So if we go 10 divided by this, Does look cool though. Kind of like it. Gives it this like 3D vibe, which I'm not too sad about, but it's not relevant to anything. It's not actually a grid that helps us like define meters, for example. Originally, when I look at this, I need to get rid of the grid on the floor for a second as well. I think we just need a plain color. So let's take a look. Go in folder. Let's just put, it's too bright. Let's go dark gray. Gray with an E or gray with a A? I'll do. Just leave it there. Okay. So it is definitely the wrong way around. I need to play with this off screen so I can still see what I'm doing here, which isn't going to work. It needs to be in the viewport there. Okay. Now one can see that. I need to change the material instance so I can see the small gray grid a little bit better. So that's the small grid. Let's just go. It'd be pretty cool if you were like being chased or something, that it would be like red. Okay, so we'll just save that away for a second. Okay, so you can see that grid actually moves a lot nicer now. The small one actually stays with our world, right? Okay, and so next we want to do that to the large grid as well. So where's our large grid? It's right here. Just need to change large grid size. Okay, so that's a lot nicer. Cool. So now everything is scaling like originally, so it's one small grid line for every meter and one large grid line for every 10 meters. Might actually scale it up a bit, so it's like 20. These are now 20-meter units. Also want to change the thickness of the line based on the map scale. I don't mind the small ones becoming invisible, but these large lines, they start getting aliased after a certain point. So we'll go back into our material and use this map scale for the line thickness as well. What we'll do is get that line thickness and just say 0.1. Here that's too large. That's okay. Zoom out. It's the wrong way around. I think it needs to be a division so that it gets higher. There we go. So just that grid line now, because when we were getting smaller it was becoming too alias, we just divide the value, and so as this gets smaller or larger it changes the size of the thickness, and so it's still readable, and then when you zoom in you start getting your small grid, which is cool. So that's everything on the zoom handled. So let's update our Photoshop checklist. Feels real nice. Changing this checklist takes ages and I need to get a better tool for it. Okay. Alright. So we're on the last part now. We've got an hour to do markers that are going to be displayed across our map, similar to this style here. So let's get... There's a bit of a jump. There's a bit of a jump. Okay. Don't know why there's a jump. Something to do with the to function. But anyway. So what we need for a marker system, and this is just how I always do my marker systems, is create a new folder. Let's call this markers. We'll have a new blueprint class that's an actor component called BP marker registry component. And that goes on our HUD class. So one cool thing you can do that I like to do sometimes is you've got this description here. Exists on HUD class, listens to new markers on begin play of those components or upon activation. OBS Studio disconnected. Are we still live? Listen to events. Just gonna check out. I'm gonna check out the stream on my phone. Changing this checklist takes ages and I need to get a better tool for it. So what we need for a marker system, and this is just how I always do my marker systems. I'm just watching the stream right now. one cool thing you can do. Yeah, so I have been having some connection issues, and it doesn't tell me exactly when it drops, but let's just carry on. So I'm going to describe this one more time. There's a marker registry and a marker component. Marker components get dropped onto actors. They have the configs of how it looks and behaves. They send that they've activated or deactivated to the registry. Or rather, they have a delegate that performs that. All the registry does is acts as a hub that we can listen to in any UI. So we could listen to it in a compass, we could listen to it on a HUD UI for like real world things. And in this case, what we're going to do is we're going to listen to it on our Holomap. So let's just get started creating other components. So blueprint, actor component, BP marker component, or BP marker underscore component. Actually, I prefer to do this as a scene component. So let's go blueprint scene component. This just allows you to offset it without having to hold that as a variable. BP marker component. So that's cool. From here, what we will do, smite. Is this how I want to do it? So usually this is how I do it. This is usually how I do a marker system, because now it's like decoupled and you can use it in various use cases. But for this one, I'm drawing it on that map on the ground. And I know I'm going to use widget components to handle the drawing, because that's just going to be quicker and simpler. And I add it to the world asset. The world route that gets scaled and moved, and that means that all those markers exist in the way I want them to exist. Let me think here. I want it to... How do I want this to behave? Or be set up or drawn in particular? We at least know that we're going to have some data that represents our markers. So let's at least start with the data assets. So if we go to blueprints and type in, we can get this primary data asset here. And so we're just going to call this data underscore marker. And this can now hold some information. So we'll say there's a texture. It's a texture 2D. And we use this as a soft object reference. So now we can reference an icon like this, and it should be fine. We'll add a color for now, and I think that'll do us. I think we're just gonna we're not gonna add any other special stuff. We'll just add texture and color. We could do scale. We'll do that as a float. We'll just set that to 1 by default. The color by default can be white. We'll do it at like 0.5 opacity. And there won't be a default texture. We won't force there to be a default texture. And now that we have this data asset that we've created, we can actually go into miscellaneous, go to data assets, and actually pick to create a new marker. And so from here, I like to do DA underscore marker. So we know what type it is, even though we could infer that, or we could learn that from hovering it. But I like to keep it in the name, so that if you type marker into the search bar, it comes up. So a marker underscore, and we'll just say, I'm not going to take too much time on this, but basically location A, B, C, and D. And so that could be like hospital, base, camp. It could be anything, right? I'll tell you what, I will theme them. Let's keep it division theme. So let's go medical, military, let's go. What would you call a population place or a town or camp? I guess. Call it a camp. Medical military camp. Do outpost. We'll do stronghold. So we've got probably like 1, 2, 3 friendlies and 2 danger kind of things of different scales. So we can play with that as we create our system. What I like to do with these as well is, now that I've got my markers, I like to have just a folder called core and then a folder called variants. And so I put all my core logic in my core folder. I put all my variants in the variants folder. Sorts that out. I am going to need some iconography for these, but let's not worry about that for now. So we've got our marker. We've got our marker component, which is going to have a data variable, right? It's going to have a data asset that is a marker. So DA marker or data marker, I think I called it. So that can be an object reference, because if this exists in the world, we know we want to know about that data. We already know we need to know. We already know that we need to know. So that's a variable of this class. And so now, because I've selected specifically the data for the markers, the only options I get in this list are of those types. So that's our default setup for a marker component. The next thing that needs to happen is we would get the player controller, we would get their HUD, and we would get a component by class, we would get a registry, and then we'll need a function to register the marker and to unregister the marker. So event destroyed or event end play. I have to do a switch here. In fact, we'll probably save a reference to this. I want to have as little data as possible on these markers, because there can be a lot of the markers. Another thing I want to do is turn off the tick on this scene component. Look, it doesn't need to tick, neither does the actual registry. So we'll disable both of those. In our registry, we do need 2 functions. So we need register marker and we need unregister marker. And so these will take a marker component as an input. Okay, so we have register and unregister. And from here, what we actually do is promote this to a variable. It's called tracked markers. It's an array. Don't care about doing this. So let's add this. We always like to add uniquely in this case. We don't want to add extra ones. And then we'll have an event dispatcher marker registered. This will have marker. So that's the marker component. And then we'll actually have the registry as well. Just makes it easy. Registry. Makes it easy to get the registry when we're bound to this event. So it's like, here's the marker that changed and here's the registry, so that you can get the tracked markers if you need to. So that's for marker registered, and then marker unregistered. So it should be the same. Get 2 variables. This is the registry. This is the marker component. So when we've registered a marker, we're just going to call marker registered, and that means that we can listen to this registry from our compass or from our Holomap. And then we've got the unregistered marker. Oh, we've actually done this all in the unregister, so we need to do this in here. What I'll do is rename this to in marker. Okay, in marker. What I will also do is add a branch that just says as long as this was more than or equal to 0, i.e. we actually added it uniquely and it wasn't previously otherwise called, which would actually be a cause for concern if that had happened. If it's not unique, what I could do is I could print a string that just says error registering an already registered marker. So that's something we don't really want to happen. So in the unregistered marker, what we would do is we would remove an item from the list and we would do a similar concept. So we'd have an error here that's just unregistering an unregistered marker. Like, that marker was never registered, so why are you trying to unregister it? It's not necessarily an error in this case, because the way that this works is if this event occurs, we're going to unregister the marker, and the marker may never have been registered. So it's not technically an error in this case, but registering it twice is kind of an error. So I'm actually going to remove this. I could just put this as a warning. Now I don't want this printing to my screen. And I do want this to print to the screen because this is a definite error. Okay, so we call the marker registered here. So what we should do is call marker unregistered here. In marker. Self as the registry. And so from here now, we have sort of the foundations of a registry-based marker system. Register marker. There is a pattern name for this in the oldie pattern books. It's design patterns or game programming patterns, and I can't actually remember what pattern this is, but we're using it. Okay. So now that we've got our marker components registering to this, what we can do is we could say, okay, this particular building is going to have a new scene component that is a marker component. So BP marker, just call it 1. The data for this, we'll just make this military. Because it's a scene component, we can actually move this around and just say, you know, we want it at the top here. So that's the information for that particular marker. Setup. Now in our Holomap, we're going to listen to that information, and we're going to draw the actual visual representation. So let's make sure that our HUD is set up first. So if we go Window, World Settings, look at our game mode, create a new HUD class in episode 5. Just call this BP HUD episode 05. And here we'll add the registry. What we'll do is if we edit this, we'll create a new variable called debug. And if we are debugging, then here we want to say append registered, and then we'll take in marker. actor. Get the owner of this. We'll shove that in there. So what this does is it tells us a marker was registered. This is the marker, which could actually just get the data. Let's use the name of the data. So it's like a medical marker was registered from the cube. That's what this will output. And that's only if we're debugging. And so we'll do the same over here. Actually, this is unregistered. Unregistered this marker from this actor. And so this is unregistering a marker. Cool. So what we can do is in our HUD, we've got this debug variable here. We'll turn that on. And then when we hit play, we should theoretically get a marker has been registered as a print. Let's go and check. We want to print this to the screen. Make sure that that's printed to the screen there. Registered a military marker from the SM Cube 12. So that's the core. You can get rid of those. Next, we want to create a function that's bind to marker registry. Registry. So what this does is it gets the player controller. It gets the HUD. It casts that to, well, it doesn't even need to, it just gets the component by class. We'll just get the registry. So for anyone joining right now, what we're creating is these markers that you see on this 3D world map. We've got the ability to define where they're going to appear and the type that they will appear as. Like this is a medical, this is like some sort of camp, this is energy, I guess, but we have that data. We've created that data here in our marker variants. We've got different types, and the things that we can define in here are the texture, the color, and the scale. When we drop that onto an actor in the world, in the details panel, we can select which type of marker it's going to be. We're now creating the binding for the marker registry, which we have on our HUD. Anytime a marker gets created, that component that we just saw on the cube, anytime that gets created, it just sends a ping out to the HUD and says to the marker registry and says, hey, register me. We can wrap that in some logic that's like activate on start or activate on demand. So you can have markers that are innate until later. Yeah? But for now, for this demo, we're just going to do it's always active. So we have the player controller HUD registry. So what we can do is bind to marker registered. And we can also bind to marker unregistered. This, I might not script this second part because I only have 50 minutes, but we'll see. Let's just create some events for these. We can create a matching function. We'll just call this on marker registered. Go back here, create a matching function for this on marker unregistered. Okay. I actually kind of want to do this entire section in its own component because we are just bloating up the Holomap, but I'm not going to worry too much about that. If you wanted to organize your code a little bit better, you would not necessarily code this directly into the Holomap. You would maybe have something else that does this generic register unregister event driven logic, and maybe then you would bind to that. In fact, let's do that. Let's actually do that. I think that sounds cool. So in our markers, in our core, we'll actually create a new blueprint class. It's an actor component. It's a BP marker registry listener component. And this literally just does what we were doing, but allows us to do it without creating these functions. So what we'll do is we'll take this code, we'll put this on begin play here. What this does is it finds the marker registry, and essentially on marker registered, can have another custom event on marker unregistered. This can have its own delegates on marker, registered. Registered. So now I can drop this onto any actor and I can immediately bind to these two events without having to recode that binding setup. So if I want this on the compass or I want this on minimap, some of those things don't have actors to drop components onto, so it might have been better to do this through, I don't know, subsystem maybe. It would be better to do this through a subsystem, to be honest. So we have these two events. We're basically daisy chaining this out. So let's just go marker registry. I guess what we could actually do, I wonder if we could do this. Rather than doing a component, let's make a blueprint function library. So we have a BPFO underscore marker registry. And we have bind to marker registered. Marker registry. And so that gets this. This should be fine. And then you basically put these out here like this. And so this is event registered. And this is event unregistered. Call that. Instead of having that core component that we were creating, this marker, we got the marker registry, that needs to stay. We've got the listener. We don't necessarily need that listener. So what we can do is when we bind to marker registry here, I could actually just put that straight in my event graph, bind to registry. And I get two events, which just create. So I don't need this bind here. We've now promoted that, if you like, to something that anyone can do. And then you just pick your two events here, on marker registered, on marker unregistered, compile that, and this should be fine. So on marker registered, let's just print hello. So that did not do exactly what I wanted, and I think I know the reason why. So when we call the binding, what we need to do is take this registry, get tracked. So the first time that we bind, we need to actually call this event registered a couple of times. To essentially trigger the hello. So there we go. So that's just like a latency thing. So that solved that. Okay, so we've got our Holomap and we've got our two events. From here, we're now going to actually create widget components that will represent the data that we were looking at. So we will add a widget component. Let's create a widget and set this widget to the widget that we created. We're gonna actually, I don't know what's going on with my mouse right now. We're going to attach this component to the world root. We will snap, may as well keep world scale, may as well keep world rotation as well. And we may as well keep the world position of the marker. So what we're going to do is we're going to set world location. Set relative location. Set relative. We're essentially going to place this marker onto our world root, which is the thing that we're scaling and moving around. We're going to just attach it at what would have been the world location. So, set world location to get marker. Get marker. Hello. Get marker. World location. And then the location rule will say keep relative. I think this works. If it doesn't, then we'll just change how we're organizing the position. It's a manual attachment. We actually need to create the widget that represents these markers. So just create a UI folder here. New user interface widget blueprint. So widget underscore. We'll just call it generic marker. Sometimes I would create a base class for this that I would have some core functionality in that is like receiving the data. So let's actually do that. So we have this widget marker master. When you're creating a master widget that's just going to hold data and function rather than appearance, what I do is I go into the class settings and I set this to be an abstract class, which means it can't be selected as a widget that is in a UI. So what we can do from there is just create a child class of that widget. So now we have what the marker will look like. So we'll create a child widget underscore marker underscore generic. We'll just do generic. The thing that a marker takes is marker data. So just call this marker data. It has a variable of this and it is exposed. And that means that when I create this generic, see how I can only pick the generic marker? We get the marker data. And so that's what we can get from this asset. Happy days. Another thing that I would like to, well, actually, it would be probably smarter that instead of sending just the data, we actually send the marker component. Because then we can get the world location and other information from that marker. So let's just refresh this node and we actually get the marker. So that'd be a little bit nicer. Don't know why my mouse keeps disappearing. It's actually quite annoying. Okay, so we created a generic widget. Can I have my mouse back? Thank you. Okay. Alrighty. Marker component. So that comes in. It doesn't really need to do any logic right now. There's nothing to really code in the master in this case, but it is a nice habit. So in the generic one, we'll actually create our appearance. So we're going to have an overlay. It's going to have image. We will set this to desired size. Let's check this image size here. We'll go with, yeah, we'll stick with 32 by 32. So that's how it will appear on screen. We'll make sure that that's a variable. So image icon, come in here, set brush texture. Actually, it'll be from a soft texture. Because what we do is we get marker, get data, get texture. And so this is the data asset that we made previously for our military camp, outpost, etc. So that sets the appearance of the marker. I'm not validating any of this, but sometimes you would add is valids in there. So from here, we need to at least set up how this widget behaves. So we don't want it world, I want it to be screen space. I'm also going to add a beam that comes from these, but we'll do that afterwards. The widget it creates is just null. It should just be null. Yeah, none, right? I'm going to draw it a desired size, pivot 0.5, 0.5. That's cool. It doesn't need to tick, so we'll turn that off. That should be everything there to create a widget that takes in an appearance. So we're using the military marker and we don't currently have a texture in there, so we'll just use this green icon for now. So let's check that everything triggered as we expect. So this isn't getting hit. Probably want to match the size of the original. So we do set a widget. We have created a widget. We have a component. It has a world location. What I need to do is draw a point. So as a debug point, we're going to draw it at the marker's location. Size 50 for 50 seconds. And then I'm going to do the same thing again after we attach it. But this time I'm going to draw it in blue. It's 25. There should be, oh, so there is two markers up there. And this isn't attached in the way that I want it to be attached, right? Like, it's not actually moving with the miniature world. So that's not cool. What I could do, potentially, I don't actually know. One thing that I'm worried about is that we're not getting a construction event. That's like one of the things that I'm concerned about right now. We are creating this generic marker. We'll probably take this marker type from the data as well at some point. So we'll have a variable of a widget that we'll actually provide. So we've got this. We're adding this widget component. It's in screen space. It doesn't have a widget class. It's drawing at a desired size, which is technically, I guess, nothing. Let's actually set this to 32 by 32. And then we set the widget here. Of course, I don't see anything, so I don't know if there is actually a marker up there. It is supposed to be drawing in screen space though, so it's definitely just not working right now. We do set the widget. I think the construction is never going to run. Let's try that. Get rid of some of our hellos. What's going on here? We don't have a marker. Yeah, sure. Let's just plug that in. We've got another hello somewhere, which of course is just the curse of me sticking hellos everywhere. So let's go find out where those are. Still not getting marker start here. So when we hit this, we should have already had that print. Like, this does exist. It has been technically pre-constructed. We're just not receiving. Yeah, we're not receiving any events from it. I wonder if they changed something. Because usually this would just work, like you would just add it. Maybe the tick needs to be enabled. Ah, now we have it. Yeah. Ah, there we go. So it did work all along. So that's great. It worked the whole time. So all we need to do now is create a widget material for the marker so that we can fade it out when our animation plays. It does start every single time that you run this, which is interesting. Okay, so it did work. The issue was that I had the tick mode set to disabled. So what I'll do is I'll put automatic, so it's only ticking when necessary. Which means apparently it doesn't tick at all. So I guess this is going to have to tick. Can I then set tick mode to disabled after the fact? Apparently not. So that's a shame. If there's a lot of these, it might be quite expensive. Zero, are you still there? We wanted to have a look at the performance, and before I get any further with this, maybe we should do that. Because this is going to be probably the most performance impacting part. So yeah, it looks like there's only one person viewing, so I'm guessing that is Seri. So we'll check CPU and GPU later towards the end, and we'll finish off with this marker. So what we have now is a basic marker that moves with our world, which is what we wanted. And we are now just going to style it, make sure that it's fading out when we open and close the asset. In order to do that, because this is a screen space widget, we actually need our widget marker to know about the Holomap in this case, which is a shame because this is meant to be a generic marker. What we could do is we could create a Holomap variant of a basic marker. And so in here, what we'll do on construct, if we have a marker component, we'll set the texture to its data, and we will get player pawn, pass that to 0.5, get the Holomap, get the child actor, pass that to a Holomap. So now we have a reference to our Holomap. And from there, what we can do. Actually, no, we don't need this because we have a radius. We actually have a radius for this. So what we want to do is we want to essentially replace this with a retainer. If I can do that. Might get a little bit expensive, but we'll still see. Replace this. Okay, so wrap it with a retainer, I suppose. Just replace this with the child. What this retainer box does is, we'll call this retainer box fade. It has an effect material. So if I go in, create an m_UI_fade Holomap. Holomap marker. And plug that in here. It has this texture parameter. So we'll convert this to a parameter called texture. That just goes into base color. I think this needs to be UI. Texture object. We need a texture parameter. That just goes in. I think this is going to be translucent, so we'll take the alpha as well. And by default, we need to give it something. So we'll give it a default white. Now in our Holomap, if I change this to red, yeah, so it's that material is taking in our information, and we know that that's the case because if I set the final color to nothing, it should be the case that, yeah, so this is black now. So you can see that's actually taking in the data that we want. Now for this opacity, what we do is if we go to grid material, m_grid, we can actually take our logic here. So we have this map anim radius. We can do some distance logic for that. So we have a map anim radius. We have this retainer would essentially need so I need to set some variables on the retainer. So set scalar, okay, get material, get the effect material, set vector, set param. This is audio, we don't want that. Because we need to know the distance basically between the position of it and the position of the player in the world, and then some sphere masking logic essentially. I'd rather not create a material instance for every single one of these that's drawn on the screen. What would have been nice at this point, if I had the time, I would maybe actually draw this to a panel on the HUD. So these widgets would actually be on that panel and they'd be updating their position. And I would put one retainer on top of the whole thing and then just like fade that away. So another option that we have is just controlling the render opacity of the marker or the markers as that grows out from the center. And it would be on that widget component. So yeah, instead of this, I'm going to replace this with, it's just going to be cheaper basically. Replace this back with its retainer box. We're not going to create a retainer box effect for this. We are going to instead create our own widget component. So you've got this widget component here, you can create your own one. BP widget component. In here, what we will have is a function called init holomap. I guess actually no, we might be able to just create a variable for the marker component that it's relevant to. Have that as a variable that is exposed on spawn. And back in our Holomap, when we add this widget component, instead what we'll do is add a Holomap widget component that actually comes with a marker component. So we just plug that in. We take the rest of this logic around setting the world location, setting the widget, and we just take all of that. I'm still going to attach it to the parent. That's fine. Still going to be manual. Then begin play. What we can do is create the widget from our marker component. So we want to know the data. We need to set the world location of this widget to the world location of the marker. It does afterwards get attached to the parent Holomap. So what I would maybe do to make this make more sense to someone reading it in future is actually have this parent component as a variable that's exposed. Because you kind of want to read this and it makes sense as you're reading it. So this is just like create widget and attach, create widget, set world location, then attach relative to parent, which is the Holomap root. So that it's so that it's offset correctly in local space. Refresh this now, we get our parent component, and so that's all that marker registry does. It just creates the widget. And what we can do is we could actually store a map. So if we promote this to a variable called marker components, create a map here. It's actually the marker component is the key, and the value is the marker component. Marker widget Holomap component. So what you can do from here is add, and it takes the marker and it takes this. The reason that we're going to store this is that when we unregister, what we want to do is find the marker, and then we now have this widget component which we can destroy, assuming that we actually found it. That's just in the event that you're actually going to remove a marker. So that's how you would clean this up. I'm not going to test that. There might be some quirks around the actual widget within the marker component needed to be cleaned up or removed from parent. So we find it, we remove it, and then we remove the marker entry in the map. So now there's no empty entries. Okay, so finishing up on the approach I was going to do. The reason I wanted to put the reason I wanted to create a widget component like so is because I can store a variable for this widget, which is marker, or widget marker, I guess. Marker widget. And I can play with the opacity of that when we're animating. When we're animating the in and out effect, I'm going to essentially set the render opacity to get scalar parameter from game, which is the radius, get the world location of this actor, get the vector parameter from our game. Should be our player position. Yep. This is just an XY. Oh no, it's a linear cutter. Okay, cool. So we'll just say vector. It's a vector. Cool. Got world location here. Can't do a sphere mask. It's not material. So we just want the distance from one to the other. We're going to come out with a opacity that basically fades away as the radius just passes over our position. So if our distance is, say, 500, it's not going to be rendered. In fact, right now, if I open this, oh great, it's broken. Let's just double check what we did wrong. So we made a new widget component, but we didn't set up the defaults. So this is screen space, none, 32 by 32, and enabled. That should hopefully fix it. Yeah, cool. So if I zoom all the way in and move away, you can see that the markers that are outside, their opacity is actually wrong. So what needs to happen is on tick, we need to set the render opacity from 0 to 1. Map range clamped, I think. The value is the distance from the center minus something about this anim radius. It's like, are you within the anim radius? I guess what we could do is say, we do need both of these variables. We could do a percentage, and we could add an offset to that percentage. So this is the max. This is the current. So if we did divide by the max, and let's say the value was 100, and the radius is currently 50. Percentage would be like 2. Like this. I'm just going to try this briefly. It's inversed. Okay. Part divided by the whole, and then we actually want to move 1 minus in here. No. We want to maybe clamp this, then oops, then 1 minus this. Yeah, so what we do is we add a value to this to offset it. We just add 250, which is the maximum size, which might mean it's always 1. I've done that wrong, so let's go half. That's nice. I'll go with that. It's not exact, but but it's pretty cool. And so what I'll do as well on begin play is I'll just make sure that that has 0 render opacity to begin with. Not perfect, but it gets the job done. Always flicking at the beginning. Yeah, so something about it being a 0 was maybe messing with some of the logic. That's good. I'm okay with that. Enemy perfect is the enemy of good in the prototyping phase, and if we wanted to play with the performance, we could take a look at doing this in a different way. I would want to have like some single material that controls the fade in, fade out of those widgets, and I wouldn't have a bunch of widget components representing the positions, so that I don't have to have a bunch of widget components. And I would use like a matrixed cylindrical fade on a screen HUD element instead. We're at 11 minutes and we have a couple of things to sort out. So firstly, we need game icons for our 5 types of structure that we created. So we've got camp, medical, military, outpost, stronghold. Having a look at this website here. This like I don't want black. There we go. Just go away. Color 0. Enter 1. Seriously gonna make me put 1. I can literally see it. There we go. If you type 0.00, it works. Weird. Okay, so download that PNG. We've got a camp, so we'll go military. This looks like a good one for a stronghold. Let's go rank 3. Rank 2 is cooler. Let's download that one. We'll go hospital. Yeah, we'll use that. PNG for that one. We'll do outpost. It's a cool one for outpost. We'll do stronghold. Fort. I mean, yeah, it's not going to be perfect. Do like a shield. Go for this checkered shield as our fort icon, maybe. I don't really like it. I want to go for this castle. Sure. Okay, so we've got 5 icons now. Put those in. Asset actions. In fact, I could just go sprite actions, apply paper 2D settings, and that will do most of the job. Because we're just trying to save some time quickly. We've got the camp. Open all of these up. So what's this one? Stronghold. Outpost. Medical. Camp. Cool. Camp we'll do in blue. Hospital we'll do in green. Outpost we'll do in maybe like an orange, red. Stronghold we'll do in red. And then there was military. So we'll do this one in dark blue. Okay, so that's all our different marker types. In here, what we want to do as well is set color. Opacity. We'll just come off here and we do color. Plugs in there. What we can do is split this. No? Okay, what's going on with this? This is color, not linear color. So we can edit this. Just do linear color. Hopefully it's retained the colors in here, which it may not have. Yeah, no, so it changed them all. Right, okay, so stronghold was red. Yeah, that's just not working. Let's just do one at a time. Stronghold, red. Copy. Got a military structure there. However, we do not have coloring, which is interesting. Military color. Strange. Set color and opacity like this. Nope, still not colored. Really strange. I wonder why that's not coloring. Just double check this. Not getting a breakpoint anymore. It's definitely being constructed because otherwise it wouldn't set color. Oh, actually, marker registry. Let's go here. I think I know the problem. The problem is that our widget component isn't using our Holomap variant. Okay, cool. So we've got a color on there now. It doesn't work great because of some design issues. So instead of coloring this, what we'll do is we will place this with an overlay. Does not need to be a variable. We will create image circle. In the back, we'll add a couple of units padding. Circle will be full size. Do we just have a circle? We'll do. Actually, no, you won't do. That might do. I just want a white circle. Ugh. Okay. Let's go and export a white circle. File, new, 32 by 32. Put these into our variables here, import. No. Put it in a random folder because I'm rushing. Okay, and that icon should be above it. So we're going to set the color of the circle. It's kind of cool. We've managed to crunch the icon, which I didn't want. So what we'll do is we'll take the circle and we'll do a transform. This isn't going to work. Let's just get this icon here, set it to central. And in our widget component, in our class defaults, where we're setting this up as 34 by 34, we'll just set it by 32. We'll just make it bigger, basically. There we go. So we have this dot. The corners do bleed over, which, again, it's bigger. It's not doing what I want. It's rendering out a widget that I want to be that size, and it's rendering the center strangely. So let's just try this. No, it's still stretching the internals, which is kind of annoying. So this would be how it would appear. This is how it should appear. If I don't match size, won't it just be massive? Oh. Oh, I see what was happening. Match size was making it like 256 by 256. Okay, cool. So this looks good. The only other thing that we would want to do is just test out the different types. So we are running over a little bit, but let's test out the different types of icons. So we go to our details, copy this. We'll just place it on a couple of different actors. Use a camp. Go here, add post, stronghold. Back here, add medical. So we have a couple of icons now on our map that tell us like what different things are, and from here you could do some other stuff. You could enable the mouse to pick one of those icons and actually click it and then move to it. So that would be pretty cool. So what we've done today is we've fixed the grid. We've added, well, what we've done today is we have added the zoom. That was one of the first things that we did. We fixed the grid when we zoom, and we've added these markers. That bit took about an hour. But the markers are pretty cool. So happy with how that turned out. Take a little picture of that. That was cool. Thanks for joining. That's going to be the end of this particular session or series on doing this holomap. I think we've got something pretty cool. Got different types of buildings that we could play with in the future as well. Nice little marker manager component that does what we want it to do. In terms of stat game, we are looking at around 1.5 ms for the world tick time, and we could take a look into stat U objects to check out what might be affecting that the most. The holomap is 0.5 ms. We also have various references to the holomap, maxing out at 1.5, 2 ms. This add component 0.25 ms, that's the waypoint line just happening over and over, which we'd want to replace with Niagara. For the update waypoint path, that would obviously get removed as well. So update waypoint path at 0.45 ms and the add component, those would both go if we were to change to Niagara. The general receive tick we could reduce when we're not moving and not zooming. We could eliminate that cost, and so it would only cost while we're moving. We could also depending on how many things I'm actually moving right now, we could actually reduce some of the movement cost as well, because we wouldn't need to run as much code. We could run moving just like one asset around. On the rendering, yeah, we've got it is like bad. It's not covering the whole screen, so overdraw is pretty good. And then we're looking at just removing that when we go back into our main view, so that's not too bad. Yeah, overall not too bad. We could also go stat UMG, stat slate. So there is a decent amount of tick time on that slate, and that's to do with those markers essentially that are in our world space. If we made a ton more of those, I think we would. Well, even now the total slate tick time is not really acceptable, unless that is. No, it's not. It is a little bit representing the things that are already drawn on screen, but not so much. So I think that is actually almost definitely related to these 3D markers. Although when I remove them, it doesn't go down. So that might just be the default cost. So we've got stat GPU as well. So nothing crazy on this. Obviously, we're not adding anything to our shadows. We're not adding anything post-processing wise. So I think we're pretty good. That's it from me on this episode. Catch you in the next one. Cheers.